G'day. In a previous episode I made up an arbor with an M3 taper on the end of it, and that was destined to become a holder for a cutter. And to finish that off, it needed an M3 socket to go into, and most lathes come with these things supplied, but if you're buying second hand, of course, these things go walkabouts, particularly when people don't know what they're for. Now, these are actually quite important because, and this is the one that I made up for this lathe here, a centre goes into that, and then you use that for turning between centres. So a nice accurate diameter without any misalignment and all that sort of thing, and be able to put that back in and all that sort of stuff. Typically you'll turn between centres. So that was missing, so I volunteered to make up a couple, which I did. So I'm going to show you the method for that. Unfortunately, they both came back because in this particular case I think the taper in the machine isn't what it's meant to be. It's an import machine, and so possibly a little dicey. This one I just made a mistake with my setting up my gear, so I had to do that again. So I'll show you that towards the end. Now, a couple of people were commenting on the button tool that I use. I don't know whether you can get them. The branding on the front there is Traylor or something like that. Trayor. And it's also half cut off here is a Carbaloy brand. So hopefully if people are looking for these, that'll give you a head start as to where you might be able to find them. It is a handy tool if you're going to be cutting profiles or something where if you've got a sharp tip tool, it's not quite right. The downside, of course, is that the tip is rather broad, and so you can get chatter and that sort of thing developing. I'm going to be doing several of these, including one that I'm going to keep because I've got an adapter which takes Morse 2 to Morse 5, and Morse 3 might come in handy one day, particularly if someone asks me, can I make up a mandrel for them? So I'm starting off by doing the blank preparation, so I need to take that down to, I'm making these things 2 1/4 inches, and then I'm going to put a 3/4 inch hole through because that'll be under the size of the small end of the taper, and that'll give me something that I can then work with my boring bars to taper that out. Now, one of the things that I had to work out for myself was how to get a length of material face down accurately. So what I do is I face both ends, leaving a little bit extra, and the reason I face both is my saw doesn't cut as square as in within a thou or two, so it's safer just to face both ends. I'll then take that out and measure that, work out what the length is, what I want it to be, and then I'll come up with my compound. And this is the way that I do it. There might be other ways. I'll lock the carriage, and then I'll come and touch off with the tool here, right? And you can feel it. It's not difficult. Then I'll adjust my compound dial here and zero that. Come off and then dial in the amount that I want. Now this one is actually 88 thou, so I'm going to do 40, and then I'm going to do the other one simply because I don't want chips all over the place. But that's basically how I face things down to length. And so if I look at this one here, which I've already done, I get that I'm 1 thou under. I'm at that point where I have to admit that there are sometimes no really good choices, but just a collection of equally bad choices. When I set this taper up, I used this drill bit, and I was cutting a taper like this, so the tool is going away. Now I want to use the same setting, and the setting worked really well. I want to use the same setting for these adapters, which means of course the small end of the taper is going to be down here and the big end is there. The disadvantage to that is that I can't put this in there to gauge how good the taper is, but on the other hand, because I've got a sharp corner here, as in the corner is going like that, I can measure that diameter. So what I've done is I've put some mark out fluid on just at the end of the bore here, and that'll help me work out when I'm getting close to the end of the bore. I'll be able to work out what that diameter is and what the diameter should be based on my length and my taper, and as long as I'm a little bit under that, that should give me the socket I want. All I'm doing at the moment is putting an internal Morse taper 3 bore in these blanks. So I've got this one, and then I've got 2 of these as well. So I've done my first pass with that's removed the die chem in there. Now measuring that, I get 0.77 and I need 0.825. So I'll just take that out, probably in 2 steps or so, and fingers crossed I'll get the taper I'm after. This is the setup that I'm using to cut the tapers. Basically, I've chucked up a bit of material here, turned the M3 taper on it, put a thread on the back there for a nut and also for a spacer, just to allow me to get reasonable clearance. But because I've turned this up and I haven't touched it since I chucked it, this taper should be perfectly aligned with the axis of the lathe. What happens then is, if I then put my blank on with a Morse, matching Morse taper in it, that means that the axis of that Morse taper is perfectly aligned with the lathe. So therefore, when I go and cut the outside taper on, it makes the two concentric, which is what you want. If I tried doing it in another way, and there may be other ways of doing it, but if I tried doing this by, say, putting this on a plain taper, or cutting the outside taper and then holding that somehow in a form, and then putting the inside on, I probably wouldn't have much luck. It'd probably be wonky in some ways. So this is probably about the best way to cut an adapter like this. There are a couple of ways to set up to do the external taper. So this is one of them. This is if you haven't got a taper turning attachment and have to use your compound. What I've done here, I've put a couple of marks roughly 1 inch apart. I say roughly because I've run my compound against a dial indicator and have verified that 1 turn is 1/8 of an inch, so I need to do 8 turns. So these are just there to give me an idea that, yeah, I'm around about the, where I should be. What you do is you look at the taper per inch for the particular taper, and bear in mind most of these tables refer to it as a taper for both sides. So if you're doing it for one, you need to halve that. But then what you're doing is running the dial indicator along for 1 inch, and the indicator should deflect the amount of taper. I think so the taper for a Morse is not precisely, is around about 50 thou per inch. So I should get a deflection of around about 25 thou. I'll verify what that should be. But I then juggle the angle of the compound so that I get that deflection when that's happening, and that will then give me the taper I need. I'll then machine that down to taper. So here's the taper after I've run up and down with the compound set at the angle. It's only a degree and a bit. It's not terribly much, and so you can do this. Well, if your compound has got enough travel, you can do this relatively easily. In fact, I found the worst part was actually trying to get this thing set properly. The actual machining was relatively straightforward. So that's one way of doing this. The other way is I'm going to use the taper turning attachment device again. Similar arrangement to get the taper, but just makes it a little bit easier. I'm setting up to do the angle on the taper turning device. Now, when I was using the compound, I was able to use the screw on the compound to move the compound along 1 inch. Here I can't. I've got to use the saddle. Now, if I had the DRO fitted to this lathe, then I could use that to give me my readout. Instead, I'm going to have to use my dial indicator. Now, this is actually how I set things up. I want this to travel an inch, so what I've done is I've got a bit of inch round stuff. This is just a miscellaneous part which is here for a future project, and I've got that set up so that the dial just deflects to a particular spot. I usually just use 1 revolution. So between there and there, when the dial is in the right spot, I've got 1 inch. If I now bring the carriage along so it comes back to that same deflection, I've just travelled 1 inch, and so that's how I'm going to do that. So this is actually a handy way of setting up a stop if you want to, and you can use something like a drill bit shank or something like that, or something like this, some gauge blocks, whatever. If you have to, or if you use a dial gauge for getting your travel. All done. So there's the M3 to M4 and the M3 to M5, and the way these things work is that they go into the headstock, and then you can mount a centre, or in the case of the arbor that I turned the other day, you can mount the arbor using a drawbar, but then do all sorts of finish turning on there, and that will give you the final product. Now this one is this is referred to as an M5, but it's actually the back end of the M5, which strikes me as a little bit odd, but that's what the manual says it is, so who am I to argue? This is an MT2 that I did some time back, same principle, goes in there, but the reason this has got a recess is that you might be able to see there are a couple of marks there where the cam lock cams are just sort of chipping in. So I thought, well, while I had it up there, I'd put a recess in there so that there's a little bit of clearance there, and that'll just slide in there nicely. I just made this one up because although I don't use M3 tooling, I thought, well, sooner or later someone's going to come along and say, I've got an M3 and can you do something for me? Just as I was thinking how well this had gone and all that sort of thing, these two came back. This one, the M5, doesn't fit, and I'm not quite sure why that is, because using the same setting I made one for this lathe, and it fits quite nicely. So what I'm going to have to do there is work out some way of gauging it so I can then measure what the taper actually is and set that up. It's a pain, but that's sometimes the way you've got to do it. You have to make the parts to the machine rather than make the machine to the parts. This one is straight stuff up on my part. Although I set up my compound and all that sort of thing, I didn't check it once I'd started cutting metal. A couple of thou out on the taper per inch, which means I'm out, what was it, about 10 thou on the end here, enough to make it not fit. So I'm going to have to redo this one. To do that, it's actually a bit of a pain, because to get the precise centre I need to recut this. So I've had to set the taper turning attachment back up to an M3. I'll then put this on here, set this up to the M4, or what the M4 should be, and then take a cut. But there's a lot of work involved, because yeah, to get that concentricity, you've basically got to do the whole thing again. So I guess the lesson from this is, if you're making up parts for a machine which isn't next to you, and so you can't try them immediately, you're sometimes better off to leave your setup there so you can just get back to it. But unfortunately I had to use the lathe for something else, and so the setup got broken down. I've got to start again. This is the reworked M4 on M3, so I've got my M3 mandrel, and as I mentioned earlier, I took a light skim off the surface of that to make sure it was actually true. I've put that on, clamped that up, and then recut that taper. Didn't take off much, but I had a bit of black text around the top here, so I could just tell when I was touching, as that was the smaller part when sitting in the matching taper, and then took it off down towards the tail end there. So hopefully that'll work. We'll have to see. The M5 to M3 is going to be a little bit trickier. What I'm going to have to do for that is make up a measuring jig, and it'll probably be something similar like this. So a disc with a basically a knife edge, sharp edge there of a known diameter, sliding in another disc slightly larger size, try that in the spindle, measure that distance, and then because I know what the distance from there to there is, I can take that away and work out, you know, what the taper is over those diameters. So that's how I'll have to do that, and that's a story for another day. So thanks for watching. I hope this has been of interest, even my stuff ups, and we'll go from there.